Welcome back everyone for part 2 of our lecture series on wind, ocean, and El Nino. And so if you want to just, I'm going to pause here on the Cornell notes. If you want to hit pause too and jot some of that down, it's probably a good idea if you don't already have it. Definitely a good idea. Before we jump into ocean currents, one last point about just air circulation. And so if we think about air pollution, our air pollution, here we are in the United States, we're getting hit by this band of wind called the westerlies, which means they're coming from the west, blowing towards the east. Notice the polar easterlies are coming from the east, blowing west. And so all of our air pollution, if we're getting it from in here on the west coast, is coming from Asia. And then also, if you think about like acid rain, we are, contributing to that, but we don't really see it because all of our air gets blown over here. So air pollution obviously knows no boundaries and or borders. And so let's jump into the ocean circulation here. So the good news is if you look, it really kind of matches up with air circulation. And so up here is where our trade winds would be. These are the trade winds down here, by the way. And so if you look, that arrow kind of follows the arrow down here, and down here in the southern hemisphere, same thing. Same thing over here. Here this looks like the polar easterlies. And so the wind pushes the ocean currents, and of course there's high tides, low tides caused by the gravitational pull of the moon. We're not going there right now. We're just focused on the wind. And so the wind pushes the ocean currents, but of course you got all this land that gets in the way that makes everything way more complicated than it would otherwise be. And so, for example, you remember Central America used to be underwater, and so the currents would go right through. Now that it's not underwater, it makes a difference. Okay, and so really the thing to remember about the wind and the ocean currents is the wind is pushing the currents, and it gets a little bit messy in there. And so enter El Nino event. In normal circumstances, you get something that looks like this at the equator, right? So here's our trade winds. They're strong from that Hadley cell, and they push the water to the west. And what that does is it takes the warm water on the top and it pushes it towards Indonesia in this area. So if you want to go scuba diving and snorkeling, go over here because it's super warm. As you probably know, the ocean by us here in California is super cold. And the reason for that is because once that warm water gets pushed out of the way, cold water is able to come up from the bottom. So it's kind of the opposite of convection. But it's a good thing, because what it does is it's called an upwelling, and it brings all the nutrients from the bottom here that's sunk in the ocean. It brings it up, and the fish love that. And so here in Peru, where the El Nino is really pronounced, the fishing industry is really good when it's not an El Nino year, because there's plenty of food for the fish. And so the fishing industry is really good around Peru until the El Nino hits. And so it's not fully understood why this happens, but here's what happens. Those trade winds get weaker and actually maybe even stop. And so there's no longer the winds pushing that warm water over here to the west. Now it can actually reverse sometimes. And so this warm water hangs out here, or even it gets really warm, and the upwelling doesn't happen, and so basically the fish leave, and there's definitely a hit on the ecosystem. The fish leave, and there's a hit on the economy too. But not only that, the weather goes crazy, and so the ocean affects us in a lot of ways. I've got some surfer friends, and maybe some of you surf, and on an El Nino year, there's an El Nino, a slight El Nino in 2013. It was just a light one, and even then the water was quite a bit warmer here in the ocean, 5-6 degrees Fahrenheit warmer. Back in 1997, there was a huge one. It had record-breaking snow in Tahoe. It was awesome for skiing. But the weather goes crazy, and now all of a sudden you've got tons of rain here, and we had tons of rain in San Francisco in 1997. And places where you normally get rain, now they don't get it. So you got droughts, you've got floods, you've got blizzards, and it's not just happening here. Now you don't have the warm water over here, and so it affects Australia and Indonesia too. And really you get a global effect. And so I've got a little video I want to show you guys right now. I'm about to blow your minds because we're going to do a YouTube inside of a YouTube, but I thought that this would be pretty good to kind of bring it to light. Here you go, check this out.
The notion that a drought in Indonesia or the Philippines could be caused by the same conditions that produce torrential rains in the United States, Peru, and Chile might appear to the casual observer to defy logic. But in fact, that's exactly what can happen during the extraordinary chain of events known as El Nino.
Nino is the appearance from time to time of warm water in the central and eastern Pacific Ocean. Normally there's a pool of warm water in the western Pacific, and that's because of the way the earth turns and the winds blow. Water piles up in the western part of the basin. The sea level along Indonesia and the Philippines is higher by 60, 50 centimeters than it is off the coast of Peru. So what happens is the winds keep blowing, the water piles up, it heats up in the western part of the Pacific. But then once in a while, it could be every 2 years apart, it could be 10 years apart, that wind weakens and that warm water that's piled up sloshes back towards the central and eastern Pacific. Where the warm water is where you get your evaporative processes, evaporation, and clouds that produce rainfall.
Now that has an effect locally, as you can imagine. Ordinarily, with all those rain clouds over Indonesia, there's a lot of rain in that region. There's rain over Australia. It's fairly dry in the east. During an El Nino, when you've got all this convective precipitation over the east, it can rain a lot in that region. You can have flooding in Peru. Conversely, you have drought over Indonesia and Australia. It can also have effects pretty far away, and the reason that happens is the atmosphere can support these wave-like motions. It's just like dropping a pebble in a stream. Although the pebble is at one little place, the ripples can go very far away. So those ripples...
And I'm back. I think we captured it there. And so the thing I'd like to close with about El Nino is this question we had: what does this all have to do with climate change? And does it have anything to do with climate change? A lot of people think that El Nino events are happening more frequently, and there's still a lot not understood about them. But and it's very difficult to make a cause and effect relationship. But this is an article from 2013, fairly recently. Get out there. So see, Scientific American study strengthens link between El Nino and climate change, and that's important because an El Nino event, when it's pronounced, which oftentimes it is, it means the weather gets really crazy, lots of damage to the economy and crops and food and fishing industry, and so it's really it's definitely extreme weather events come with that, and so we like to keep those extreme weather events to a minimum. All right, thanks a lot for staying with me, you guys. We'll see you next time.